So we have installed Keil. Let us come to the lecture number 13, where we'll see the demo of using Keil. Keil is an integrated development environment. Now we'll be using this Keil for development of software for microcontroller. Now how to create a project and all this thing that we'll discuss here. So we can go here and say we'll select this new project. I have already created one folder here and we'll be creating one more folder. Suppose project number 2. Here it is project number 2, and let us give file name as demo. Save. Now then it will ask which microcontroller you want to use. For example, I will be using Atmel and I will be going for 89C51. So it shows me the description about 89C51, how much RAM and timers and all this. I'll say okay. I will say no, I don't want any startup code. So I'll say no. So here it is, a target folder is created. Now I will create a new file. Suppose I'll start writing a program here. Now suppose here org 0h, okay, and jump main, discuss what is org and all that. Here org 30h, and here it is main. A very simple program I am writing here. Suppose I am sending some data into accumulator, say hash 35h. Then in B register, move P, comma, hash 40h. Then I will write an instruction add A, comma B. Stop here, system here, and here it is end. Now let us save this file as extension .a. Now you can see here I will say add .a. Okay. So now this is an assembly file, so that's why it has changed the colors and all that. Now what I need to do, I want to add this file in this source group. Select here .a. You can see this file, add here, close here. So now this file is available in this source group. Okay. Now we can build this file. You can see 0 errors, so it is able to build this. Now we can set other things for target, like I can set here options, and here output. I can check this if I want a hex file to be created. Okay, and say okay here. Now I can debug this program step by step. And say here start debug session. It shows me evaluation mode. We want to debug this program actually. So we need to go in the debug mode. So you can say start stop session. Okay. Now you can see this yellow cursor here. So right now when we reset, we know that program counter shows the 0. So this is what the first location of ROM. Here I have this code. I look at this, the code memory 000, and this 80 and 2e is what I can say assembly code of sjump here. And the purpose of this is like we want to jump at this main location, and actual program starts from 30h. Sorry, Now why 30H? Because actually we need to leave some space for ISR. Now we'll see interrupt service routines and all that. So purposely we have kept some locations blank and our actual program starts from 30. But by default, when we reset, it goes here. So this is actually assembler directive. See, org, and these are assembler directives. We tell assembler that we need to put this code at 0h here like this. We again tell that we need to put the actual code from this point at 30h. So 30a org, and these are assembler directives, and these are actual instructions, what we can say actual program is here. Now we want to debug this, so now the cursor is here. So we can say program counter is in reset state. It is showing the first address from where execution should start. You can see the program counter here. It is showing like this. Now I will execute the first instruction, so it will jump here. Look, this yellow line now it is next instruction to be executed. Now program counter showing us the 30. Now I will execute this step by step actually. Now look at the execution of first instruction is there, and this 35 is now available in accumulator. Now again next instruction, you can see this second instruction is executed. The 40 is available in B register. Again next, now see addition is performed. You can see 75 hex number is available in accumulator. Now here S jump here. Now see, we don't want to move further, so I'm just writing this S jump here. Here means it will stay here in infinite. You can say infinitely it will be executing here. It will not go in next instruction. Actually this is not an instruction, it's an assembler directive. So S jump here ensures that it will stay here. As we execute again and again, it will just stay here. So this is what we have executed. Now we can close this debug session again and come back to editing. I can say we can again edit the program, and suppose we want an hex file. What we can do here, I can say rebuild all target files. See, hex file is generated here, and you can check that hex file at our folder, whatever the folder we have created. You can see the hex file there. For example, I have created this in my folder at 015 project 2. Right now you can see this is the hex file which we can burn actually in actual microcontroller. So this is what we can now start doing the programs in assembly. Now we'll see one more lecture that will be writing a program in embedded C. Thanks for the watching.